So this is another lecture on definite integration. In the earlier lectures, so far we have integrated several problems on definite integration, like integral f of x dx in the interval a to b. So what we did was we integrated f of x. Suppose integral f of x dx. Suppose integral f of x dx is g of x plus c. This is from indefinite integration. There is no interval. So when you are integrating the same function, when you are integrating the same function in the interval, the only thing you do is you do not write constant of integration. The c you do not add. You don't add c. What else will you do? You will enclose this in a bracket and you will write a to b. Then you will evaluate this by substituting upper limit and the lower limit. So wherever x you have in the function, inside the bracket, you will write upper limit g of b minus g of a. That is what you get. So we have evaluated quite a lot problems, and right now we are doing a section where we are integrating the functions, but we haven't studied any new ideas of integration. What I mean to say is, this f of x which we are integrating, we are using all the old techniques, results, theories that we have learned in indefinite integration. Everything that we have done in indefinite integration, we are using those techniques only. The only thing is now we are evaluating in an interval. Everything that we have done earlier, we are using, but in an interval. Okay, so as such, you can say, if in indefinite integration problem you had solved 400 questions, if you had solved 400 questions, those all 400 questions can be done once again in an interval. Definitely, we are not going to do 400 questions, but we will solve at least 25-30 problems. So in the same, we will go ahead, and I'm taking the book which I am referring to. It is Maharashtra State Board, exercise 4.2 from paper 2, exercise 4.2 and question number 2. And what I will do is I will solve the first one, question number 2 first. So let's have one more question. Let I equals to 0 to 1 upon root 2, 0 to 1 upon root 2. We have here sine inverse of x, sine inverse of x upon 1 minus x square into raised to 3 by 2 dx. So this is what we have. We have to integrate this. 0 to 1 upon root 2 sine inverse of x upon 1 minus x square raised to 3 by 2. So see, what do I write? I write this as 0 to 1 by root 2, 0 to 1 upon root 2 sine inverse of x divided by 1 minus x square into 1 minus x square raised to half. What I do is, this 1 minus x square raised to 3 by 2, first I write it as 1 minus x square into 1 minus x square raised to half. Okay, as you know, if the bases are same, power gets added and you get raised to 3 by 2. Okay, so right now my aim is my aim is to integrate this. Somehow I should first see your first aim is to integrate. Once you will have integrated, then only you will be able to evaluate upper limit minus lower limit. So first I will integrate. And for integration, what are the steps that we have studied in indefinite integration? We have list of results. We have list of results. So whenever I see any function to be integrated, I just ask myself whether in the list of the results I have this function. So if the answer comes no, in the list of results, if I don't see such a function, then what I do is, if I don't have any such functions in the list of the results which I know, then what I do is I go for transformation. I go for transformation of this integrand. The one that you want to integrate is integrand. So you go for transformation of integrand. Now, what is the meaning of transformation of integrand? That is, you will not change, you will not make any change in the value of the integrand, but you will make change in its form. You are going to transform. Transform means you are going to bring change in its form. Okay, so sometimes simple transformation works for us, and sometimes we have to use substitution. So here I think we will have to use method of substitution. So since I'm not able to integrate directly, I wrote it this way. In the next step, you all know, see, this is raised to half, and something raised to half is actually square root, right? So the next step, I will write this as square root of 1 minus x squared. So this is square root of 1 minus x squared. Okay. Now what I write is, I write here, see, I go for substitution. I write, put sine inverse x is equal to t. I write sine inverse x as t. I go for a substitution, and the substitution is, see what I am writing. I will write here, I am going to put sine inverse x as t. I put sine inverse of x as t. And as you all know, if we are substituting something as t, the next step we have to do is we have to differentiate. So differentiating with respect to x, I will get derivative of sine inverse x is 1 upon square root of 1 minus x square equals to d by dx of t. So that is dt by dx, and this dx I multiply here. So I get dx upon square root of 1 minus x square equals to dt. Now this thing which has happened here, you are well aware of this. See, the very reason for I substituting sine inverse xt is I understood that when I will have differentiated, I had understood this, that when I will have differentiated, I would get derivative of sine inverse x, I will get 1 upon root of 1 minus x square. And see, I have this here. I have it here, you know, I have this 1 upon root of 1 minus x square, and here I have dx. See, this thing I will get after derivative. So I will put this as t. Okay. So this thing will be this whole thing here. This whole thing here will be dt. You understand? This whole thing here will be dt. But the problem here is this will go dt, and this thing is t. Fine. But the actual difficulty is for this. What would we write for 1 minus x square? Remember one thing. Once you have started writing the integral in t, you cannot have anything in x. Okay, because you are going to now write dt there. You know, dx upon square root of 1 minus x square, you are going to write dt. So if you have started writing dt, you have to have everything in t. So for that, what we will do is this. See, I will write sine inverse x is t. This implies x is equal to sine t. You see this? This implies x is equal to sine t. So this will become 1 minus sine square t. Now, okay, very fine. But still there is something which we will have to look for. And you know what? That is we got interval. 0 to 1 by root 2. Remember students, this 0 to 1 by root 2 was an interval for the variable x. It is the variable x. See, you are integrating with respect to x. So it was the variable x for which you had the interval 0 to 1 by root 2. Okay, x goes from 0 to 1 by root 2, but you are not going to have the integral in x anymore. It's going to be in t. So you'll have to write a new interval for t and see. So since you are going to have everything in t, you will have to change it. So you will here change the limit. You will write when x is 0, x is from 0 to 1 by root 2. So when x is 0 and when x is 1 over root 2. So when x is 0, this is the place where you actually establish the relation between x and t. So when x is 0, you have sine inverse of 0 equals to t. Sine inverse of 0 is 0. So t is 0. T is 0. Then you have x is 1 by root 2. So when x is 1 by root 2, you have sine inverse of 1 upon root 2 equals to t. Sine inverse 1 by root 2 is pi by 4. Pi by 4, because sine pi by 4 is 1 upon root 2. So you have t as pi by 4. What is t? T is pi by 4. So now you have the new integral. You have the new integral with the new interval. And what is this? What is it going to be? See. Therefore, I equals to 0 to 1 by root 2. You will not write 0 to 1 by root 2. What you will write? 0 to pi by 4. 0 to pi by 4. Then sine inverse x, you will write it as t. Okay. And this whole thing is dt. You will write dt. What is now left? 1 minus x square. 1 minus sine square t. 1 minus sine square t. You see this? Sine x is sine t. So x square is sine square t. So next step you have I equals to 0 to pi by 4 t upon, you have t upon cos square t, t upon cos square t dt. And what is cos square t? 1 upon cos square t is sec square t. So you will have next step as 0 to pi by 4, I equals to 0 to pi by 4 t into sec square t dt. Okay, and see, this is now integration by parts. So this is integration by parts. So here I will write integrating by parts. Integrating by parts. And as you all know, when we integrate by parts, we check the functions. There are two functions. This is algebraic and this is trigonometric. Now we have to go for the priority code. What's the priority code? It is LIATE. So here we have algebraic, then trigonometric, and in the priority code also it is same. It is same. A is before T. So what we have is proper. So I will go for, now I will take this as U. This is U always. The first one that you have is U and the second one is V. And as you know that in integration by parts, U and U is never integrated. It's only that later function which is integrated. So I write I equals to T integration of sec square T dt minus big integral d by dt of t, again integration of sec square t dt, and then bracket close 0 to pi by 4. Okay, you write complete and then write 0 to pi by 4. Okay, don't write 0 to pi by 4 here, 0 to pi by 4 here. No, nothing like that. Okay, and yeah, there is one dt which is missing. That also I will write. See, this is, and then here this completes, and then here 1 dt. Okay, 0 to pi by 4. This dt is for this integral, and then this dt is for the outside integral. Now, once you have written, see, there are three integral signs. So no confusion where to write this limit. Limit we will write. We will enclose everything that we got in a bracket and then 0 to pi by 4. Now I equals to, you have t, integration of sec square t is tan t minus integral, this is d by dt of t is 1 and integration of sec square t is tan t, 1 into, this is 1. So 1 into tan t is tan t and again dt, and then here you have 0 to pi by 4. So now next is I equals to t into tan t minus integration of tan t dt is log of sec t, and then again 0 to pi by 4. You don't have to add c, this you remember. Okay, 0 to pi by 4. Now the next step that we have is known as upper limit minus lower limit. And what does that mean? It means wherever you have t, you will write upper limit. Then wherever t you have, you will write lower limit. So the upper limit here is, so you will write therefore I equals to, now inside this bracket, wherever t we have, we will write pi by 4. So we will have here pi by 4 into tan of pi by 4 into tan pi by 4 minus log of sec pi by 4 minus log of sec pi by 4, and that is, see, this is upper limit. Wherever t I have, I wrote upper limit. Then wherever t I have, I will write lower limit, okay, and that I will subtract. So minus, now I go for lower limit. Now wherever t you have, you write 0. So you have 0 into tan of 0 minus log of sec 0 minus log of sec 0, and then okay. So I equals to, you get tan pi by 4 is 1, so pi by 4 into 1 minus sec pi by 4 is root 2, because cos pi by 4 is 1 by root 2. So you got log of root 2. Okay, this is 0 into tan 0 is 0 and sec 0 is 1. Log of 1 is 0. So the second bracket is fully 0, because 0 multiplied with any number is 0. Tan 0 is anyway 0. So 0 into 0 is 0. Furthermore, here you are going to get sec 0. What is sec 0? 1 over cos 0. Cos 0 is 1. So 1 upon 1 is 1. Log 1 is 0. So you get here, second bracket is 0. So this is your final answer. You have pi by 4 minus log root 2. So root 2, if you want, you can write 2 raised to half. So you can have that I equals to pi by 4 minus 1 by 2 log 2. This is your final answer. So let's take one more question where we have 0 to pi by 4. There is a correction in the textbook. It is written as 4 pi, which is incorrect. It is not 4 pi, it is pi by 4. So please do the correction there. So 0 to pi by 4 sine 2x upon sine raised to 4x plus cos raised to 4x. So once again, I have to integrate this. Now, what do I understand? I understand there is no ready-made result available for this. So I will go for transformation. And what is transformation? Very interesting. I will divide numerator and denominator by cos raised to 4x. I write here, dividing numerator and denominator by cos raised to 4x, we get, see what you will get. You will get I equals to 0 to pi by 4, 0 to pi by 4 sine 2x upon cos raised to 4x. So sine 2x, I'm writing 2 sine x cos x, and here dx, this dx I wrote here. Okay, 2 sine x cos x, and down here I have sine raised to 4x plus cos raised to 4x, the whole divided by cos raised to 4x. Okay, now what will happen in the next step? In the next step, you will notice that it is 0 to pi by 4, and this is down here cos raised to 4, and here I have got cos x. So I'm left with 2 sin x. Cos x is cancelled. This cos x gets cancelled with 1 cos x. And since 1 cos x is cancelled, I'm left with cos cube x. This here I'm left with cos cube x, which I prefer to write as cos x into cos square x. I prefer to write that as cos x into cos square x, and this dx is written for this. Okay. Now down here I will split the denominator. So this is sine raised to 4x upon cos raised to 4x plus cos raised to 4x upon cos raised to 4x. This cos raised to 4x is cancelled. The next step I get is therefore I equals to 0 to pi by 4, and I get here 2 tan x. 1 upon cos square x is sec square x dx. 2 tan x and 1 upon cos square x sec square x dx. Here sine raised to 4 upon cos raised to 4 is tan raised to 4x, tan raised to 4x plus 1. So the next step I write I equals to 0 to pi by 4. I write here 0 to pi by 4, 2 tan x into sec square x dx, 2 tan x into sec square x dx, and here tan raised to 4x, I will write tan square x the whole square plus 1. See, this is what I did. Okay, tan raised to 4, I wrote tan square x the whole square. So the next step is I will put this tan square x, I will put tan square x as t. I put tan square x as t. Why so? Because see, those who are very good in derivatives, they would not be finding this question difficult. Why? Because what I see in the numerator, it is clear that it is derivative of tan square x. If you do not know, just differentiate d by dx of tan x the whole square. D by dx of tan square x. What it will be? It will be 2 tan x, 2 tan x into d by dx of tan x. That is 2 tan x into sec square x. Now the moment when I saw this 2 tan x sec square x, the moment I saw 2 tan x sec square x dx, I understood that this is what going to be my substitution. So I will put tan x, I will put tan square x as t. I will put here tan square x as t. So the next step is I go for substitution. Put tan square x equals to t. As you all know, after substitution, the immediate next step is differentiating. Differentiating with respect to x. So d by dx of tan square x equals to d by dx of t. Tan x the whole square. Okay, this is 2 tan x into derivative of tan x, which is sec square x, equals to dt upon dx. Now this dx multiplies here, so you get 2 tan x into sec square x dx equals to dt. So now you know this whole thing will be dt. This thing will be t square plus 1. So the whole integral problem will now shift to t. What should the next step be? We will now try changing the interval, because remember 0 to pi by 4 is for x, not for t. And here you have substituted tan square x as t. So when tan square x as t, what will happen to interval? That also we will have to finalize. Okay. So here I write here when this 0 to pi by 4 is for x, it is for x. So I write here when x is 0 and when x is pi by 4. So when x is 0, see, I get here what? When x is 0, this is where you will substitute, because this is where you established the relation. This is where you had established the relation. So here only you will substitute for that. So you get here tan square 0 equals to t. Tan 0 is 0, so t is 0. Next, tan square pi by 4 is t. You put x as pi by 4. So you get 1 square equals to t. T is 1. So what will be the new interval? The new interval is 0 to 1. Okay. Now this is old integral which will now be getting transformed into t. The old integral is in x. Now we will write everything in t. So see here what I will get. Therefore, therefore, I equals to 0 to 1, and you remember what this whole thing is, 2 tan x x square x dx, it is equal to dt. Then here you have dt, and then down here you have tan square x, the whole square. What is tan square x? Tan square x is t. So t square plus 1. T square plus 1. That is next step I write 0 to 1. 1 upon t square plus 1, I'll write 1 plus t square. Okay. Or let it be the way it was. I write here t square plus 1 square and dt. Now this is from first set of theory. That is, if you remember, we have done this in indefinite integral where we wrote 1 upon x square plus a square dx as 1 over a tan inverse of x over a plus c. So here it will be 1 over a. A is 1. So 1 over 1 tan inverse of t over 1, t over 1, and then 0 to 1. You got that? Now see, 1 upon 1 is 1, so it hardly makes any sense writing those. So it is tan inverse of t and 0 to 1. Now what? Upper limit minus lower limit. The next step is upper limit minus lower limit. So we get here I equals to, wherever t, write upper limit. So tan inverse of 1 minus tan inverse of 0. Tan inverse of 1 is pi by 4. Tan inverse of 1 and tan inverse of 0 is 0. So you get the answer as pi by 4. This is final answer. Very interesting question. You must watch this again and practice it well. This question here, we are having 1 upon 5 plus 4 cos x. If you remember, in indefinite integral, we have done or type 1 upon a cos x plus b sin x plus c, a cos x plus b sin x plus c dx. Or you have 1 upon a cos x plus b dx, or you have 1 upon a sin x plus b dx. Any of these three integral, if you integrand, if you have any of these three, okay, any of these three, if you have, what was the method? The method was we put tan x by 2 equals to t. We put tan x by 2 equals to t. So x by 2 will be tan inverse t and all that. So you can refer to that video in indefinite integration and you can check that. So here I will write, see, I will write here put tan x by 2 equals to t. So if tan x by 2 is t, x by 2 is tan inverse of t and x is equal to 2 times tan inverse of t. I differentiate with respect to whatever x or t. So with respect to t. So here I get d by dt of x and here I get 2 is a constant out. D by dt of tan inverse t is 1 upon 1 plus t square. So you have dx equals to 2 dt upon 1 plus t square. The next step you do is you go for C. In all such questions, now when you will go for writing t, when you go for writing the integral in t, look at this. So for 1 dx, you would be writing 2 dt upon 1 plus t square. Now the question is, what will you write for cos x? Very simple. The idea is very clear. It was this cos x, which I had thought of writing using the formula. This cos x I had thought of writing as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Remember, this cos x I am viewing at cos x. I am viewing at cos x this way. I look at cos x this way. That was the reason I put tan x by 2 as t. So if cos x I view it as this one, so cos x will be 1 minus t square upon 1 plus t square. Now the next step, I changed the interval. Interval is 0 to pi by 2. Always write 0 first here, okay? Please. You write here. Some students have habit of writing upper limit first and lower limit second. Don't do that. Lower limit first. So when x is 0 and when x is pi by 2. So see what you will have. When x is 0, right here 0. So you have tan 0 by 2, that is tan 0 is t. So 0 equals to t, t is 0. When x is pi by 2, so right here pi by 2, so you have pi by 2 upon 2 as pi by 4. So tan pi by 4 equals to t. This is pi by 2, so pi by 2 upon 2 is pi by 4. So you have 1 equals to t and t is 1. So now everything is set. You will have here the integral I will be, therefore integral I will be. Don't write 0 to pi by 2, it is 0 to 1. 0 to 1 and 1 dx is, what is 1 dx? It is 2 dt upon 1 plus t square. And then here you have 5 plus 4 cos x. 5 plus 4 cos x is 1 minus t square upon 1 plus t square. And now you can complete it. See, you will have now, therefore I equals to 0 to 1 2 dt upon 1 plus t square, and here the LCM is 1 plus t square. You have 5 into 1 plus t square plus 4 times 1 minus t square. Okay, and what happens next is this 1 plus t square gets cancelled. 1 plus t square gets cancelled. Therefore I equals to 0 to 1 2 dt upon 1 plus t square gets cancelled. So 2 dt upon 5 plus 5t square plus 4 minus 4t square. So I equals to 0 to 1 2 dt, and here you have t square plus 9. 5t square minus 4t square is t square plus 9. So this is this 2 I will write out. So I 2 I write out 0 to 1 1 upon t square plus 3 square dt. So here you will have I equals to 2 times 1 upon a 1 upon 3 tan inverse of t by 3 and 0 to 1. This 1 upon 3 can be taken out. So you will have I equals to 2 upon 3 tan inverse of t by 3 and tan inverse of t by 3 0 to 1. So now you have upper limit minus lower limit. I equals to 2 by 3 and tan inverse of 1 by 3 minus tan inverse of 0 by 3, which is 0. Tan inverse of 0 is 0. So the final answer is 2 upon 3. 2 upon 3 multiplied with tan inverse of 1 upon 3. This is your final answer. So let's have one more question. The next one is negative 1 to 1, 1 upon a square e raised to x plus b square e raised to minus x. I will write negative 1 to 1, 1 upon a square e raised to x, a square e raised to x plus b square divided by e raised to x and dx. Why do I do it? Why do I do this? It is because I understand that e raised to minus x in denominator is e raised to x. Now I will take the LCM. So here I take LCM, see what do I get. I will get here so I get here I equals to negative 1 to 1, negative 1 to 1, 1 dx, and here LCM is e raised to x, 1 dx, and LCM here is e raised to x. I get here a square e raised to x square. What I get? I get a square e raised to x square plus bx plus b square. Okay, so what I did, I had here a square e raised to x plus b square upon e raised to x. So a square has the denominator 1. So the LCM was e raised to x. And then the first term, I got a square e raised to x square. This e raised to x square gets multiplied here plus b square plus b square plus b square. Next step, now this e raised to x will go up in the numerator. It will go up in the numerator. So what you will get is I equals to negative 1 to 1 e raised to x dx, and here you have a square e raised to x square plus b square. Now it is time I go for substitution. See, I go for substitution. So I put e raised to x as t. I put this e raised to x as t. When I do that, after derivative, I will get e raised to x dx as dt. Remember, always, whenever you are putting some part of the integrand as t, after derivative, 99% times you would be getting something to resubstitute for. That will always happen. It has been happening and it will keep happening so. 99% times it happens so. Okay, and few times when it does not happen, the problems are so obvious that we will know what is to be done. So here I write put e raised to x equals to t. Which e raised to x am I putting as t? See, it is this e raised to x I'm putting as t. And when I will differentiate, then this e raised to x dx will become dt. Okay, so I write here differentiating with respect to x. You can differentiate with respect to x or t, hardly it matters. So if I differentiate with respect to x, then I will get d by dx of e raised to x, e raised to x, and here I will get dt by dx. Here I will get dt by dx. And if I had differentiated with respect to t, then here I would have got, suppose I had differentiated with respect to t. Okay, let me do that also. Let me do that also. Suppose I had differentiated with respect to t, then what would have happened? Then this would have been d by dt of e raised to x, and this would have been 1. Okay, d by dt of t is 1. So now what is derivative of e raised to x with respect to t? E raised to x with respect to t is e raised to x. It is e raised to x into d by dt of x, and this side you have 1. Now this dt goes there. You are going to get still the same thing. This dt will go there. So when dt goes there, you will get e raised to x dx equals to dt. See, you got once again the same thing. So whether you differentiate with respect to t or with respect to x, both are equally good. So I will get e raised to x as dt. Now what is next step? The next step is I change the interval because here we have the interval negative 1 to 1 for x. So I write here when, okay, I write here when x equals to negative 1 and when x equals to positive 1. Now, which step have we established the relation? It was this where we established the relation. So when x is negative 1, so I have e raised to negative 1 equals to t. So 1 upon e equals to t. What is t equals to? 1 over e. And when x is 1, it is e raised to 1 as t. T equals to e. So now you have I equals to, it is not negative 1 to 1. What it is? It is 1 upon e to e, 1 upon e to e. What is e raised to x dx? It is dt. And a square, what is e raised to x t? A square t square plus b square. A square t square plus b square. So next step I write this as, this is very important question. 1 upon e to e, 1 dt, 1 dt, and this, you know what I write? I write a t the whole square plus b square. And it is once again, this, what type is this? What type is this result? This result is, it is 1 upon e to e. This result is 1 upon variable square plus constant square. If you remember, it is 1 upon variable square plus constant square. The only thing here is the variable is in t, okay? And there is a, see, variable square plus constant square, and the variable is in t because it is with respect to t. Moreover, you have a constant multiplied to variable, so that hardly matters, because after, when we are integrating, the constant which is multiplied to variable, we will divide by that. Okay, so when I will apply the result, let me write this thing once again. Let me write that step once again here. So what I have I equals to 1 over e to e and 1 upon a t the whole square plus b square dt. I will write this as, integration of this is 1 upon a tan inverse of x by a. If you remember, what was 1 upon x square plus a square dx? What was it? It was 1 upon a, that is 1 upon constant, into tan inverse of variable upon constant plus c. So here what is constant? Constant is b. So you will write 1 upon b tan inverse of variable, that is at upon b, and then you divide the whole thing by constant, which is multiplied to the coefficient of t, which is c. At the time of applying the result, listen to the statement very carefully. At the time of application of result, if you see a variable is if you see that there is a coefficient of variable other than 1, you will divide. At the time of applying the result, are we applying the result here? Yes, it is this step when I'm applying the result. So at the time of applying the result, I have a coefficient of variable other than 1. It is a, so I will divide by 8. Okay, I hope you all have understood. Now what, then this is enclosed in a bracket, and then 1 upon e to e. Now this 1 upon a and this 1 upon b are not going to make any difference whether you keep inside the bracket or you keep them out. So 1 over ab and tan inverse of at upon b, and here you have 1 over e to e. Now the next step is upper limit minus lower limit. So 1 upon AB. Now wherever t you have, right, upper limit. So tan inverse of AE upon B minus wherever t you have, right, lower limit. So tan inverse of A upon EB. You know what? When you write 1 upon E, that E will go down and multiply B. So this is the answer that we are going to have. This is what we have as an answer. This is the, okay, let's solve question number 13. See, I'm solving all those problems which I feel requires my assistance. Now I'm trying to cover all those problems. Having done these questions, you will be able to solve the other problems. You'll be able to solve the other problems. Every question which is teaching us something new, it has got some new idea. I'm trying to solve it for you. So here I have sine 2x into sine inverse of, sorry, sine 2x into tan inverse of sine x dx, 0 to pi by 2. One thing you all must have noticed, for so long we had been solving so many problems on definite integration, but we haven't used any new technique, we haven't used any new result, we haven't used any new theory so far as the integration is concerned. We are using all those that we have learned in indefinite integral. It's only that this time we have the interval, in the interval 0 to pi by 2. So after, once we have integrated everything, we will just evaluate the upper limit and lower limit, get the difference, that would be the final answer. So let's go here and integrate this. So sine 2x into tan inverse of sine x. Okay. See, it is quite possible that in exam you get this question without the interval. It is quite possible. It is quite possible that you get this question in exam without interval. Yes. So if it is without interval, you can still be able to solve this, but you will have to add that constant of integration with the final answer that you get. You will be adding that plus c. Okay, that would only be the difference, otherwise nothing. So here what we have 0 to pi by 2. So I begin. See, I write here, what I notice is, what I notice here is, I notice here is that there is no direct application of result. I cannot apply the result directly. So what I do, since I cannot apply the result directly, I will try to transform it. And the best way to transform is to use the substitution. If you remember, I have taught you the concept of bad variable. So see, this what function is this? It is tan inverse sine x. It is tan inverse function. You are integrating with respect to x. So wouldn't you prefer tan inverse x? Definitely yes. See, you would always prefer tan inverse x, but here it is not x. What it is tan inverse of sine x. So such things we call it as bad variable. So you remember, when it is, we have always substituted bad angle as t, we have always substituted bad power as t. Now it is time we put bad variable as t. So I will write here, put bad variable equals to t. So what I do is I go for substitution and I put sin x as t. But before I put sin x as t, you know what? I will write this sine 2x as 2 sin x cos x. So this is 0 to pi by 2. 0 to pi by 2. Sine 2x is 2 sin x into cos x, and tan inverse of sin x, tan inverse of sin x dx. Okay. Now what I will do is I put this sin x as t. So see, when I put this sin x as t, automatically this sin x will also go as t. Okay. So because I'm putting all sin x as t, so see here, I write put sin x equals to t. Now you know, the moment you substitute, you will differentiate. So you will have differentiating, you will write differentiating with respect to x. So you have cos x, d by dx of sin x is cos x, and d by dx of t. Now this dx multiplies here, so you get cos x dx equals to dt. Okay, cos x dx is dt. So see, this cos x, what will be dt, you know? This will be written as dt. This thing will be writing as dt. See, cos x dx. Cos x dx will be dt. Okay, and you know, this sin x will be t, and this sin x will be t. Everything is done now. Nothing is left. See, everything is now changed into t. So can I write the new integral? Not yet. Why not yet? Because we need to change the interval. We also need to change the interval, because this given interval is 0 to pi by 2, which is for x. And what we need to do, we need to write the interval for t. Okay, so here I go for that. Okay, I do all this thing because I prefer to write as much as the part of the solution I can write on one page, you know, one page. That's why I do all this demarcation of columns. So here I write, so here I have when x equals to 0, when x equals to 0 and when x equals to pi by 2. So here I have when x equals to 0 and when x equals to pi by 2. So which part of the solution is the relation between x and t established? See, it is this, sine x equals to t. So when x is 0, you substitute here. You have sine 0 equals to t, so t is 0. And when x is pi by 2, so sine of pi by 2 equals to t, so t equals to 1. So it is now done. See what is done? The interval was 0 to pi by 2 when the integral was in x. When the integral is changed to t, the interval will be 0 to 1. So interval will be 0 to 1. It is no more 0 to pi by 2. Okay. So I write here the new integral I equals to 0 to 1, I equals to 0 to 1 and I equals to 0 to 1 to t tan inverse t. I hope you are getting it. 2 t, this t, why this t? For this t, for this t, for cos x dx dt, for cos x dx, right, dt. Okay, and then what? Then you have tan inverse of sin x. So tan inverse of t and tan inverse of t. Okay, now this 2 is a constant. I'll write it out. So I equals to 2 is out, 0 to 1 t into tan inverse t, t into tan inverse t dt. See, this is what I get. And it is very simple because now we have integration by parts. For integration by parts, we are going to use Liet rule. What is the Liet rule? It's a priority code which gives us the order in which the function should be written. Okay, so everybody see here. I notice that t here, this is the product of two functions I have. Okay, now here I notice that is t is algebraic function. This is algebraic and this is inverse. So as per my solution, I am having order a then I. But here I notice it is not ai. It has to be I then a. Inverse trigonometric functions should always be ahead of algebraic functions. Okay. So the next step I go for is I write I equals to 2 times and 0 to 1 tan inverse of t into t and dt, tan inverse of t into t dt. Now what? Now I will go for integration by parts. So I write here integrating by parts. Integrating by parts. We have already done this kind of problems. We have already done this kind of problems. So far as this solution is concerned, I would like to inform you that I have already solved this. I have already solved this. You can see previous video, that is question number 14. Question number 14 from first 14th. It was 0 to 1 tan inverse of x into x dx. And the answer for this I have already evaluated, and the answer for this was pi by 4 minus 1 by 2. The answer was pi by 4 minus 1 by 2. Now here we have 0 to 1 tan inverse of t into t dt. So the only change that you notice here is the variable are changed. You know, here everything you have is in t and here you have in x. Okay, but the interval is same. The function is same, tan inverse t into t. Here, look at this, tan inverse x into x, tan inverse t into t dt, tan inverse x into x dx. The function is same. The interval is 0 to 1, here also 0 to 1. The only change is the variable. Remember students, if the interval is same and the function is same, if the interval is same and the function is same, the value of the integral will remain same. The value of the integral will remain same. That is, if I evaluate this, I will get once again the answer as pi by 4 in minus 1 by 2. So this will be homework for you. You will solve all this, and the final answer you will have is 2 times pi by 4 minus 1 by 2. That is equal to pi by 2 minus 1. This will be the final answer. Answer for this will be pi by 4 minus 1 by 2, and outside you have 2. So this is the final answer. Okay. You will not write directly, please. What you will do, you will integrate this by parts as I have taught. Please do that.